All right. Good morning, everyone. We'll just start with the basic introduction to IWAN and what is the normal topology we use in IWAN environments. So almost all the IWAN setup we have a hub router, hub DC probably, and we have multiple spokes, and it's just a normal DMBPN setup if we can think like that. So uh, we have devices on the hub router, which are like ASR 1Ks, or other routers. On the spoke routers, we have like ISR 4Ks mostly, or any other iOS XE devices. And we have multiple ISPs, let's say like MPLS, IWAN, sorry, MPLS, or like internet and other ISPs. So just think it like a normal DMBPN setup, but in DMBPN, what happens is we are able to send our traffic to the hub location, then it goes to the internet, and that's how we control the traffic. But what additional feature this IWAN offers is it just controls the traffic in an intelligent way. So suppose there is a jitter or like any latency on one of the links, if we have a normal DMBPN setup, our router will continue to forward the traffic through that primary link until unless until unless we have like IPSLA or something to check, we have reachability, and until the complete reachability is down, the the traffic will continue to get forwarded on that interface or primary interface, and that will cause like huge impact if there is any latency or jitter, even induced on the ISP network or on on our infrastructure. So we don't have any intelligent way to know uh, if there is latency, and we should switch over the traffic to other link. So that is achieved in the IWAN. That's like the primary objective of IWAN. So what happens is uh, we have spoke locations that is connected to our uh, hub locations through DMBPN tunnels. We have DMBPN connectivity over there. So in the underlay, let's think about how a normal DMBPN setup is. We have in the underlay normal routing, like EIGRP, or OS, I mean BGP or anything, or static routing. I mean, on the overlay we have DMBPN tunnels, right? So in IWAN, what is it? There is one more layer over the DMBPN, and that is PFR, or IWAN layer. Okay, so that PFR or IWAN layer that controls the traffic, on which interface or on which ISP the traffic should be sent, so that there is no issues, I mean, whenever there is any issue with the ISP, the IWAN recognizes that, and it sends the traffic to the other link. So let's understand like what are the major components in the IWAN environment. uh, we have master controllers that are present on both spoke and hub routers, that are mandatory, and master controllers are basically the decision makers or CPU. So whatever decision is made, the traffic needs to be sent over this link or this link, or this is a EF traffic, or AF41 traffic, and according to policy, this should be sent over this link. uh, what policies we are defining, like let's say like we are defining a policy, like if there is a jitter of more than 5%, we will switch over the traffic from primary link, which is our MPLS, let's say, to INET, which is our secondary. So we will define all our policies on hub master controller. And you can't define policies on spoke location. It's completely defined on hub master controller, and the same policies are being pushed out on all the spoke locations that are connected to this hub router. Okay. The second most important component is border routers or BRs. uh, so master controllers, they are basically involved in like policy decisions only, applying policy, discovering BRs, like the control plane. Basically master controllers are like basically the control plane of IWAN. uh, BR routers, they are involved in processing the traffic, as well as like I mean, they are involved in traffic, sending the traffic and receiving the traffic. So I mean, also, like in IWAN, we can optimize the traffic based on delay, loss, jitter, throughput, load, and cost. So we can define all these parameters on our hub master controller to control our traffic. So that's like the gist of it. uh, so this is our IWAN, this is our IWAN layers. On the, at the lowest layer, we have MPLS or internet routing. On top of that, we have DMVPN, and all the spoke locations and hub locations, and their prefixes, they all are exchanged using BGP or EIGRP. So that's like overlay protocol here, and that runs on top of the DMVPN. And over this BGP or EIGRP, we have PFR and QoS that basically controls all the traffic that is sent or received from the hub location. So this is a normal, like IWAN setup. We have a branch, we have a central site, that houses all the hub routers, hub devices. And from this hub router, we have a link to internet. So if any like request is made to reach the internet, the traffic is sent from the hub location to the internet and back to the spoke. So basically all our traffic, most of the traffic, at the hub location, the hub location, they have all the servers. And also in IWAN, most of the traffic is between hub and spoke. Some of the traffic, they have to leave the internet and go to like any public IPs as well. So we have a connectivity from the hub. So that's how the topology is here. So we can see here, all the policies are being pushed from this master controller, hub master controller router to our branch sites. And the branch sites, they install all the policies and then make the decisions. So I mean, how how the hub devices, they come to know that we have a so and so branch location. So this is basically done through discovery package. So what happens is, like uh, I mean, we have defined on our hub locations, like hub border routers, we have the reachability, we have the routing to our each of the spoke locations. And what these hub border routers, they do, they send discovery packets on all the available paths, and these discovery packets are basically to discover the IWAN interfaces. So once these discovery packets gets intercepted by these spoke locations, they discover the interface, and they respond back, to the to these discovery packets, like, okay, I hear, my IP address is this, my master controller IP address is this, and we are also running IWAN, and let's form a EIGRP staff neighborship, to make the IWAN up. So that's basically what is done here. Uh, so there are a few components involved in IWAN. First is, like, each branch location, they learn its own site prefixes and advertises the site prefixes. So all the I mean, site prefixes are basically like all the IP addresses, or networks that are present on the hub location. Like, let's say, like, we have servers in one domain, 50.50.50 slash 24, or something. So we statically define these prefixes on the hub location. What happens on the branch? On branch, we can statically define the prefixes as well, like, what prefixes belong to this branch, or they get dynamically discovered by our IWAN as well. So it's not mandatory on the branch to define the site prefixes, but it is mandatory on the hub location to define these site prefixes. Otherwise our IWAN won't come up. Okay, so let's see, like, how PFR v3 works. So first you will have to define a traffic policy on hub master controller. Okay, that policy gets pushed to the border routers, hub border routers, and from there it gets pushed to the spoke locations. uh, then when the traffic gets initiated from spoke location to access any services on the hub routers, that is we have monitors configured on these border routers, and these border routers collect these details about the traffic, and it pushes all those details to the master controller, and then master controller makes an attempt to control these traffic path and to direct these border routers to push the traffic to whichever primary link it is, or if the primary link is congested, it directs the border router to change the path of traffic from primary to secondary. So that is completely done by the master controller. All right. So we also involve here, like, we can define, our QoS classes on, or classification of the traffic, basically on the border routers, marking and everything. If like, on spoke location, sometimes the traffic gets marked before the border router on the layer 3 switches or anything, but on the hub routers, basically it is marked on hub border routers. We can also leverage nbar 2 protocol to identify the applications like YouTube, WebEx, Zoom, and all, and we can mark these traffic based on the nbar classification, and IWAN will kick in and control these traffic. So that's one like option we have. So we have how I mean, if we go deep into, like, how basically the IWAN control these traffic. So we have performance monitors. I mean, once you configure the IWAN, and in the background the script is run to make the IWAN app, IWAN up on these master controller and border routers. And once the IWAN comes up, we have automatically these 3 monitors, they get configured on our border routers. So first monitor is about site prefix learning. So whatever like any host behind these spoke locations, whenever they initiate the traffic, it goes to this border router, and it gets sent towards this hub location. And what this border router does, through this through this spoke location, through this monitor, it learns the site prefix, and it reports the site prefix learning to the master controller. uh, what is the role of the monitor too? It monitors the bandwidth, per traffic class. So after the IWAN kicks in, we have traffic channels and traffic classes formed. So it monitors basically the bandwidth per traffic class, so that we don't have any congestion or anything. Monitor 3, basically it's in ingress direction, and it observes like the probes, smart probes received or sent from the hub border routers towards the spoke. So that is basically done for interface discovery and to make the channel up. uh, so when we have nbar configured to assist in like IWAN, we have like when we configure the nbar, it basically enables deep packet inspection for all the application traffic that is going through that. And that this IWAN, either you can configure it manually through CLI, or if you are using Epic controller, you can configure the IWAN using the controller as well. So all the data collection is sent through the prime infrastructure, and the control plane and QoS that you have configured, that kicks in here. uh so this is basically like high level view of our IWAN networks. We have here hub master controller. We configure the hub border routers here. On the hub border routers, we configure basically the path names to distinguish like which ISP it belongs. Like suppose we have like 4 or 5 ISPs. So how the master controller or the border router, it will distinguish like which ISP it is. So we manually configure path names, different path names. It should be different. We can't use the same path name. So it basically uses the path names for each links, ISP links, to distinguish like the traffic that is sent over the internet. And at the same time, we configure the you know uh, branch spoke locations as well. So generally what we have is like we have master controller and border router configured on the same router in most of the customer setup. So the same one, there is only one WAN router, and that is acting as MCBR in the spoke, but we have like multiple border routers. But you also come across situation where we have like two WAN routers. So one router is acting as MCBR, and another router is acting as BR router at the spoke locations. So that's the normal topology that you come across. So here I mean, as I told you, like we have to define the path path names to distinguish the ISPs. So that you can say it's a one ISP belongs to red color, another ISP belongs to green color, and that gets reported back to our master controller, and then it controls the decision to forward the traffic to which ISP. As I told you, like how these hub locations, they come to know like how many spokes are running IWAN, and which which traffic should I control through IWAN to spoke location. So that is basically done by the interface discovery. So hub border router, it continuously sends the discovery packets to our spoke locations. So in the beginning, it sends the discovery packets with DSCP default class, and the source packet will always be 18,000, and destination packet will always be 19,000 for these discovery packets. So if you come across a case like where interface discovery is not working, or some channel is in uncontrolled state or unavailable. So you'll have to focus like why that channel is not getting formed. So maybe you can take a packet capture or packet trace on the spoke locations for that channel. So you can make an ACL with source port like 18,000, destination port 19,000, and source of that discovery packets will be hub master controller loopback IP, with which we are identifying it in the IWAN. And destination IP address will always be master controllers, spoke master controllers loopback IP. So you can just define an ACL and configure it on the spoke location and check, like if you are really receiving those discovery probes. If not, then we'll have to troubleshoot, like why those discovery probes are not being received on the spoke location. So does anyone have any questions so far? All right, so I think we are good. All right, so first is like first process is like interface discovery, or the spoke discovery that happens on the hub location. So how can you check like if a particular spook is under IWAN domain or not? So you can just run this command. So domain, this is IWAN domain name. It can be IWAN or any domain name that customer has defined. Master discovered sites, so that will list all the sites, spoke sites that have been discovered in the IWAN domain. And it also contains what are the traffic classes that have been that have been classified under the IWAN domain. So there is these two columns here. This basically tells like how many traffic classes are classified under our policies, and this basically tells us like how many traffic classes are load balanced. So if we don't have some traffic class defined, like let's say we are getting some traffic marked with AF21, and if in our policy map at the hub master controller we have not defined this AF21, so that will get classified as default class traffic, and that traffic will get load balanced. So that will just choose any of the two ISPs, because we have not defined a separate class like which is the primary and which is the secondary ISP for that. All right, so this is the
Vikalp, can you go back to the same output again?
yes,
Couple of questions and doubts I have.
yes.
Okay, these site IDs that you see under the discovered sites are
Mhm.
the branch routers. Am I correct?
Right.
Okay, and what about the site ID with all 255s over there?
Okay, so these are like internet traffic. So
Mhm.
we have spokes that are identified by their master controller loopback IP. But if
Correct.
we have some traffic going to the internet, so
Mhm.
we have not covered that traffic under our site prefix list or enterprise prefix list, right? So that gets classified under 255.255.255.255. So if
Okay.
we see site ID as 255.255.255.255, it means that traffic belongs to the internet class,
Okay.
and that traffic is going to some public IPs.
Mhm.
Yeah,
All right. Got it.
yeah. So moving forward, so this is the topology I have in our lab. So as I told, like I have just tried to simulate the hub spoke topology that customers usually have. So this is our master controller router at the top. This is like the switch that is connected to these hub border routers. So we have two hub border routers here. These two routers, they are acting as ISP routers, And these two routers, they are spoke routers. So this router I have configured is as MCBR, and this router I have configured as only BR. And this router has one link going to this ISP. You can just ignore this, like most of the customers, they have only one link to one ISP, but like I have made it like redundant link. So if you have like redundant link to the same, like one link to this ISP, one link to this ISP, you'll have to basically configure different tunnels. Like if there is four links here, like there should be four different tunnels on these spoke routers. Otherwise the IWAN won't come up. And this is like our users are connected behind these spoke routers, and that's the topology we will be using in our lab. Okay, so hub location, I have ASR 1K devices on the hub location, and they are connected to 3750 switch. I have simulated two links on the hub location. If I go back here, this link is MPLS link, and this link is INET link. Okay. On the spoke locations, we have ISR 4K routers, and behind those spoke location, we have 10.3.0.0/16 network. All right. So this is basically the IWAN domain. What are the keywords in our IWAN? We have already talked about that. Most of the customers, suppose they have like multiple data centers. So they have like one data center they will define as primary hub or central hub, and the other data centers, that will be acting as transit hub. So if there is any issue with the primary hub, the all the traffic gets shifted towards the transit hub. Or in many cases, like we have few subnets located on transit hub, we have few subnets located on secondary hub, on the primary hub. So that's how the communication will be taking place. But our primary router, primary hub device, there will be only one primary hub device, other will be transit hub. And the primary hub will how it will be identified, it will always have a pop ID of 0. So that's how you identify which is the primary hub and which is the transit hub. So this is so let's talk about the configuration. This is the normal configurations we have on our devices. So I have made a very small traffic class here. So I have just defined QoS policy for voice and critical traffic, but customers usually have more traffic classes to identify the traffic. So this is like basically the normal configuration we have on the hub master controller router. So we define master hub, source interface with which this IWAN will be identified, that will be loopback 0. And monitor interval will be like how, after how many seconds uh, the border routers will be sending the probes towards the spoke. We have to define the enterprise prefix list as well as site prefix list here. And if we are using the load balance, we'll have to basically configure this command. Otherwise it will just follow the normal routing for the prefixes that are not defined here, and load balancing will not work here. So this is basically the config we have on the master controller. uh, Two very important uh, uh, parts of this IWAN are like enterprise prefix list and site prefix list. So enterprise prefix list is basically the supernet of all the site prefixes that are defined on that hub location. So site prefixes are like what are the subnets that are present on the hub location, that our spokes will try to reach out over IWAN. So that is the site prefix, and we'll have to statically define these site prefixes and call them under the IWAN domain. Okay. So many a times what happens is like that the traffic is not getting controlled, or it's not taking a expected path. So we'll have to make sure like it is our site prefix, with to which that the traffic is sent, like let's say it belongs to spoke A or spoke B. That
Vikalp,
yes, yes, Umaveer.
I have one more question. Can you go back to the previous slide?
Yes. Hmm.
It's a silly question maybe, but yeah. So you said these two are most important, an enterprise prefix list and a site prefix list, right?
Right.
If I'm not wrong, this site prefix list basically is the list of uh, I mean the sites that are present, the branch sites that are present. Am I correct? And
No.
based on, yeah,
So
go ahead.
these site prefixes that we define on the hub location, they
Hmm.
are basically the subnets, of the servers, or whatever the resources that are present on the hub location. So
Correct.
that's what we define here. If on the spoke location also, we can define the site prefixes statically. That will cover all the subnets that are behind the spoke location, that are trying to reach these servers, or that are trying to access our IWAN domain. So that's basically it.
So you mean to say the sequence 5, 10, and 15 that is under the site prefix PFR,
Hmm.
okay?
Hmm.
These are sitting behind the spoke locations, is it?
No, these are sitting on the hub location. So we have defined
Okay,
this site prefix on the hub device, hub master controller, and
okay,
these domains, they are present on the hub location. If they would be
okay,
present on spoke location, I would have defined it on the spoke master controller.
okay, got it, okay. So why do we, I mean, of course, we have this site prefix over here having sequence 5, 10, and 15. So
Right.
again, why do you need the enterprise prefix to come here? I mean, why, what is the use of a supernet again?
Okay, so this enterprise prefix list, it will just basically cover like the top level view of what are the site prefixes that come under this. So let's
Mm-hmm,
say we have defined here 50.50 only subnet. Let's
mm-hmm.
say we have like 10.10 subnets, and 20.20 subnets.
20.20,
Yeah,
different
yeah.
subnets, right?
So we will define further here, like sequence 10, 20.20 slash
15, that's
16.
fine,
Yeah,
right?
yeah. So we call basically this enterprise prefix list. If we'll go back here, see, we have not called site. Okay, so enterprise prefix list, we have called it here. So
Mm-hmm.
basically in the IWAN design, what is the minimum requirement is like we should have a top level view of all the site prefixes that we have defined on our IWAN domain. And by
Okay.
design, that is needed here, to define the enterprise prefix list, and
Mm-hmm.
what are the subnets that belongs to this enterprise prefix list. So that's like by design, uh, implementation, we need this.
Okay.
Yeah, yeah. So
But both of them have to be there
they,
with the configs,
that
right?
is
A
that is correct.
mandate kind of.
Yes, they have to be there. I mean, like this enterprise prefix list, this is basically like the top level, like supernet of all the site prefixes. So we need to
Hmm.
define these two enterprise prefix list as well as site prefix list at the hub location.
And just to add one more question to it, Vikalp. Uh,
Hmm.
so the monitor intervals that we are configuring under the site prefix, those are the four types of traffic. For now,
Hmm.
we are letting our IWAN network that we are building over here know that these are the four kinds of traffic where the policies will be applied, basically, is it?
That is correct. Yes.
Okay, okay,
Yes, and by default, monitor interval is I think 10 seconds. but we can change these monitor intervals if we want more accuracy. So I
Mhm.
have changed it to 4 seconds. So every
Okay.
4 seconds, the probes will be sent over these channels.
Hmm.
Yeah.
All right.
Okay.
Yeah.
Yeah.
Yeah, I got it. Thank you.
So this is site prefixes that we have defined, and enterprises prefixes. On the spoke location, we don't have to basically, it's not mandatory to define these site prefixes, because they are dynamically learned from IWAN. So we may or we may not define that. So if we'll check this so domain IWAN master site prefix, this output will be same on hub location as well as all the spoke location. So this basically tells us, what is the traffic that is being initiated from the from that particular site IDs. So site IDs are basically the loopback IP of the master controller. So here we have 10.0.0.1, that is our hub master controller, and we have traffic for like 50.50 2 dot and 50.50.3.0/24. Okay, and this 255.255, this, if we'll check the flag of this is like basically our enterprise prefix list, and that is that shows as T flag, which is like top level. Okay, and we have one spoke that is identified by a site ID 10.40.0.1, which is basically the loopback IP configured on spoke master controller, and we have traffic initiated from this IP. So we can check all the IPs, or all the subnets that that are part of this IWAN domain, and which are taking part in sending the traffic or receiving the traffic from spoke to hub location. So this is a very important command, we can check during the troubleshooting. uh, hub on hub border routers, we don't have much configs. We just need to configure that. We just need to enable the IWAN here. We just need to mention that this is a border router, and we just need to reference the master controller loopback IP, and that's it. And also we need to define, if we have uh, multiple ISPs or only one ISP, we need to define a color or path IDs to that ISP. So so that IWAN can recognize, like, okay, we have path ID belonging to path ID 1 belonging to INET, path ID 2 belonging to MPLS, and so and so. Okay, so these are the mandatory configurations we need to have on our hub border routers. On the branch site, again, we need to enable the PFR using domain IWAN, and then if it is a border router, we just need to define it as a border. And if we are using the same router as master controller as well as border, then we have to configure here master local. So it means, this router is acting as master controller for the spoke location. Also, we need to define, what is our hub master controller IP. Why this is needed? This is needed because once we configure the IWAN on the spoke router, you know the spoke router will try to form EIGRP SAF neighborship with the hub border router. So if it doesn't know the which IP address the hub master controller belongs to, probably it will not be able to form that neighborship. So that's why this is needed. So this is basically to form the EIGRP SAF neighborship, for the IWAN. And the primary use of EIGRP SAP neighborship is, it does not take part in routing. That the routing will be completely controlled by our BGP, and then PFR that is running. But EIGRP SAP neighborship, that will be used to push the policies from the hub master controller to all our spoke sites. So that's how, because we are defining the policies only on the hub master controller. Okay. So I think we have already talked about, like, what are the, layers, of IWAN. Like IWAN sits at the top layer and it leverages the DMBPN setup that customers have, and it intelligently control all the, traffic through, PFR. So we can't make changes to, EIGRP SAF, configs. These are all, these gets populated automatically, once we configure IWAN. So if we want to, if we are having any issue with, the policy advertisements or anything, we can check. Sometimes, this also may misbehave. So if we can check, like, the auto configuration of, this EIGRP SAP, that is, correctly populated or not. So, this is the command to check that. So derive config check EIGRP, and we'll see, like, all the, EIGRP SAP neighborships we have and in which state they are. If they are in shutdown state and they should not, probably we should be troubleshooting from that perspective. So just to recap, like, the EIGRP SAP neighborship, that will be built between, hub master controller and hub border routers. Hub between hub border routers and hub border routers, if they have, like, if they are directly connected. So if we, connect the hub, if we have two hub border routers and if we directly connect them, then, if we check the, output of so domain IWAN border status, we will see a tunnel zero also. So that tunnel zero is basically, built for this, SAF neighborship between these hub border routers. If we don't have a direct connectivity, we don't have tunnel zero between, these hub border routers. So what is the need use of this, directly connecting these hub border routers? So in case one hub border router fails, or, there is any, issue in, traffic, traffic routing. So, the traffic can, hit our, border router too, and, it can, go through that tunnel zero to the hub border router one, and then it can, go towards the destination. So, that is, the use of this, directly connecting. But you can or you cannot, that depends upon you, like, your design, how you want it to be. There is one hub, SAF EIGRP SAF neighborship between hub master controller and branch master controllers also, between branch master controller and branch BRs. Uh, so these are, like, the possible, EIGRP SAF neighborships we can have. Uh, so the most important thing, in, for the IWAN to work is smart probes. So, once the IWAN comes up, the router, continuously sends, smart probes, on, with DSCP default, towards all the discovered IWAN sites. And, that's how we have, the, channels built over it. So if we check, like, if there is no traffic on the routers, still, if we'll check with the output so domain IWAN, so domain IWAN master, master channel, we will see, like, there are, channels built, for default DSCP class. So if we initiate some traffic for, let's say, EF or AF41, then, those, subsequently, there will be channels added for these DSCP classes as well. But, if there is, even if there is no traffic, there still will be, channel for DSCP default class here. So these are, like, EIGRP SAP neighborships we have from spoke to, hub locations. Um, so before, the IWAN comes up, the hub and spokes, they, negotiate some capabilities. So between. So if we'll check like, on the hub border router, so domain IWAN border site capabilities. So it will show like, what capabilities, I mean, it can push, towards the spoke locations. So if a particular spoke location is not, showing up in this table, then, probably there is some issue with the, smart probes and, maybe EIGRP SAF that we need to check here. So once the hub border router learns, a new site ID, uh, the local, so the local RIB, that is present on the hub border routers, that is, consulted to identify a parent route, to reach that site ID. So if we have, a parent route, to that site ID, the hub border router, it starts sending the, discovery probes, smart probes, with discovery probe flags set up, okay, to discover the interfaces, and then after that, it can send the traffic over those interfaces. So many a times, customer comes and they say like, the traffic is not getting controlled, or it is not getting controlled by the IWAN. So we will have to check, basically, like, do we have channel, traffic channels built for those traffic or not. So we have separate channels built for, every traffic classes, like, DSCP AF12, AF21, whatever traffic is passing through, we have separate channels built for each traffic classes. And it does not mean like, if we have a channel, for AF12 in reachable state, for AF21 also it will be in reachable state. It should be, but there may be some issues, with that channel. So, for some traffic, IWAN is working fine. For some traffic, if IWAN is not working fine, we will have to focus our troubleshooting for those traffic classes, for those, DSCP classes. So where we can start with like, do we have, channels in reachable state, to that, to those DSCP classes, to that particular site ID. So we can just run, this command, so domain IWAN borders channels DSCP default, or whatever the channel, DSCP value that is affected. Okay, and we will see this output. So first thing, we'll have to check like, RX and TX reachability. Are they reachable? So if RX reachability is in reachable state, it means we are getting the smart probes from the remote device. Okay. If we have TX reachability reachable, it means we have a path in our, parent routing table to reach that, site ID. Okay. Here also we can check like, if our device is generating smart probes or not. So this counter gets updated continuously. So we can see here, smart probe was sent 19 milliseconds ago, and it was received 699 milliseconds ago. So that looks fine here. We can also check like, the next hop to that, destination, or to that, site ID, that is correctly programmed here or not. Okay, so these are the things that we need to make sure, while troubleshooting any, IWAN issues. uh, Finally, we can check on the spoke location, like, do we have correct interface discovery happening or not. So what happens is like, if we run so domain IWAN master status, the IWAN domain may show up, but like, interface discovery is not happening. So if interface discovery is not happening, our traffic won't get controlled here. So this is like expected output. We see like, the name of the tunnel, the service provider which it belongs to. I mean, these things you configure on our devices through the tunnels, on the tunnel interface. And this path ID list, this is basically that color that you configured on the hub border router. So that gets populated here as path ID list. So we have 01 and 02 here. Okay. So this is like a good working IWAN, output will look like.
Vikalp, can you just go back to the previous one?
Yes.
So if at all the interface, I mean, as I as I've understood till now, correct me if I go wrong.
Mhm.
Once the configurations are put into all the devices, like starting from the master controller to the master hub, then to the
Mhm.
branch controller or the branch routers, everything is done.
Mhm.
Everything starts, I mean, the start is interface discovery. Am I correct?
That is correct. So
Okay,
so first EIGRP SAP neighborship will be formed,
correct.
and the hub master controller gets to know that, okay, this spoke got added,
These are my
and
spokes.
yeah,
Correct.
these are my spokes, and then hub master controller directs the hub border routers to send discovery probes for these spokes. So
Correct.
we already have the loopback IP of the spoke master controller, and the hub border routers, they start sending discovery probes to those to those spoke loopback IP.
Loopback IPs. And
Yes,
that's where I mean, that's where we should see these statuses as up. Am I
correct.
correct?
That
If
is correct. Yes,
if at all there is any issues, these will be seen as down,
yes,
is what I
yes.
am. Okay.
That is correct. So if the
Can
probes.
you give us one example
Mhm.
where this interface, I mean, a reason for this interface to go down when the configs are also when all the configs are correct?
Okay. So basically, I mean, recently I was trying in my lab. So what I used, I was trying a MTT tunnel, multiple tunnel, MTT feature on this IWAN. So
Mhm.
that IWAN, that feature is supported after 16.5.
Okay.
So I tried to put the same color. I basically configured the same color on both the spoke routers. So we have two spoke routers, right?
Mm.
And I configured the same inet color on both the spoke routers. Okay, on the ISP link. And that's when the interface discovery was not happening. So in that case, like we already had like all the configuration correct, but since it was the same color, the IWAN somehow recognized that, okay, there is issue, because that is not the supported config.
Not something expected, kind of.
Yeah,
Right.
yeah. So in that case, the interface discovery was not happening at all.
Okay.
So basically, the how interface discovery happens is like, whenever hub border router sends smart probes, it gets intercepted by these border routers
Mhm.
on the spoke, and it checks all the parameters received on that smart probes, and that's how it populates these interfaces.
Got it.
So what happens is, sometimes, let's say like hub border router is not generating a smart probe for a particular spoke location, or
Mhm.
like there is some issue with the service provider end, and
Mhm.
the smart probes are somehow not reaching these spoke locations.
Okay.
So in that case, the interface discovery won't happen.
Okay. And
And
these discovery packets or the are the ones which are sent with source as 18,000 and destination is 19,000, is it?
That is correct. So,
Okay.
that is the way we can identify, like, if we are
Right.
receiving the, these discovery packets or not.
Correct. I mean, these
So
discovery packets should be received on these two ports if um, there is no tweaks in the source port or destination port we make.
that is correct. So by default, these are like, defined for PFR.
Right.
Source port is 18,000 and destination port is 19,000.
So if we don't receive also, that is a cause for our interfaces not to be discovered, and
Yes.
hence it is not part of IWAN and the policies won't be pushed for that particular interface
Y-
itself.
Yes, exactly.
Okay, okay,
Yes.
got it. Thanks, Vikal.
So yeah, no problem. So I mean, we can just like quickly run a packet capture on these spoke locations to confirm, like, we are getting discovery packets or not. We can also check, like, so platform hardware, your pitch statistics drop output to check like, if our router is dropping these, smart probes. So, there will be a separate counter for that, smart probe drop as well. So that's how we can identify the issue as well. Okay. So, uh, if interface discovery is not happening for a particular spoke, we can, you know run these commands, and we can, filter these commands, because, in customer setup we have like hundreds or and sometimes thousands of spoke locations. So if I run this command, so domain IWAN master channel, we'll just, see like loads of, outputs that we don't need. So we can just filter these outputs based on particular site IDs. So if we are having issue for only one spoke, that is 10.40.0.1, we can just run this command for this, spoke location, and we can see like, what is the operational state of the, of the channel. If that is in available state, that is well and good. If that is in unavailable state, it means, there is some routing issue, and, we are not able to, reach that site. So we'll have to check the underlay and, maybe DMVPN part, for that spoke. We can see all the counters here, with respect to the, that DSCP. Here it is for DSCP default. We can get all the outputs, for all the DSCP that are, for which the packet are sent there. We can see all the counters, like, if there is any TCA received, if there was any delay or jitter, experience on that link, so that will show us all the history here. So we can basically figure out like, what might be causing this issue. If everything looks fine here in previous output, if operational state of the channels are in available state, and, there is no TCA, and still, we are not able to figure out like what is the problem, uh, then we should move on to our hub border routers to check like what is the, condition, what is the status of these channels, for that particular destination site. So if here, everything was good in my lab setup, so it was showing reachable. Okay, and this is the output you basically use to check this. We can see like, when was the last probe sent, when was it received, and, basically this channel formation, this is like the key, key parameter for, troubleshooting any IWAN issue. So one is traffic channel, and another is like traffic class. So once the traffic channel is built, then, master controller, that data is gets pushed by the border routers towards our master controller, and then master controller, run a, PDP algorithm to choose like, which path that traffic should take. And, that's when, our traffic class comes into picture, and it defines, like, okay, this is a EF traffic, it will be taking MPLS path, and, this is a traffic class for this, this destination IP. So these are, two important parameters whenever we are troubleshooting any IWAN issues. uh, this is a, like this access list you can leverage to, check for any like, issues related to, like, uh, channel not coming up, or channel coming in unavailable state, or any other issues. This is one command you can use. So PFR version 3 probe error, this is the counter you will see, in statistics. This is like a hardware drop code for this, probes getting dropped on the router. Okay, so if you want to dig deeper, like, why this probe, is getting dropped, for this PFR, you can use this command. So platform hardware QFP active feature PFR version 3 data path global section smart probe, and this will tell us like, what exactly is the reason, for those probes getting dropped. is there any routing issue? Is there like any, like issue with the ISP? I mean, what what exactly? Is there any tag conflict, no next hop? Like, we have all these, you know, counters here. And if we see, like, counters are, aggressively increasing for a particular, code here, we can, isolate, like, okay, this is the issue. Okay. Um, if, the interface discovery is not happening, we can, run this command, so monitor event trace PFR version 3 all. So this will, like just like, in EIGRP, we have these event trace, like running, and we can check, like, what is happening with respect to EIGRP, algorithm and processes. So this is a very important command in case of, IWAN. Like, we can see, like, why, how, like interface discovery is happening, how the traffics are getting learned for that IWAN, like everything related to SAF, interface discovery and IWAN. We can, see all those parameters here. This is a, when there is no traffic, and we have like two ISP links. This is the command I ran, when there was no traffic, and still we see, like, there are two channels, one on MPLS and another on INET, with DSCP default 0 class, discovered. So I mean, even when, like, once we initiate some traffic, we will see, those, channels getting added to this channel list for, those DSCP classes. But again, if I stop those traffic, then after few seconds, those traffic classes will get disappeared from this output, and only active traffic classes will be appearing here. But even if, there is no traffic, we will see these default, default channels. And here we can check the status is in available state. There is no TCA received. We can get all the information related to that channel here. So, this is the output when I had initiated some traffic. So, I had initiated traffic with AF21, EF, and we can see here, which path the traffic is taking here. Okay. So if once the channel becomes, once the channel comes in available state, that's when, like, the traffic classes, traffic class formation, it starts taking place. So, once the channel becomes available, policy decision point, which is basically a PDP algorithm, it runs on local master controller, and it chooses a perfect, egress interface or perfect channel, out of all the available interfaces, or out of all the available channels, to forward the traffic. So, this is completely based on, the policy that is being pushed from the hub location. Okay. So if we want to check the details about the channel, we can run this output. We can see, like, how the channel was learned, discovered and open, or initiated and open, so this is everything about this channel. So I think, we can continue, tomorrow from here, because it's, bin hours has already started. So, we have 2 slides left here. I'll stop the recording.